Welcome to today's video where we dive deep into the latest advancements in AI and machine learning from HuggingFace. We'll explore groundbreaking papers that push the boundaries of technology, from quantum chemistry datasets revolutionizing drug discovery to novel frameworks enhancing the efficiency of small language models. We'll also look at innovative techniques in stylogen for high-quality image editing and new benchmarks for evaluating visual language models. Stay tuned as we break down these cutting-edge research papers and their implications for the future of AI. Let's get started. $NABLA 2 DFT, a universal quantum chemistry dataset of drug-like molecules and a benchmark for neural network potentials, introduces a new dataset that aims to bridge the gap between computational chemistry and machine learning. This dataset encompasses a diverse range of drug-like molecules and provides detailed quantum mechanical properties for each. By doing so, it serves as a robust benchmark for evaluating neural network potentials, which are machine learning models trained to predict quantum mechanical properties. The paper details the construction of the dataset, emphasizing the importance of accurate quantum chemical calculations and the variety of molecules included. The authors explain the methodology behind generating the dataset, which involves high-level density functional theory (DFT) calculations. These calculations provide reliable data on molecular properties such as energy, dipole moment, and vibrational frequencies. The dataset is designed to be comprehensive, capturing a wide range of molecular conformations and chemical environments. This ensures that machine learning models trained on this data can generalize well to new, unseen molecules. To demonstrate the utility of the dataset, the authors benchmark several state-of-the-art neural network potentials. These models are assessed based on their ability to predict the quantum mechanical properties of the molecules in the dataset. The results highlight the strengths and limitations of current models, providing insights into areas where further improvements are needed. This benchmark sets a new standard for the development and evaluation of neural network potentials in quantum chemistry. The devil is in the detail. Style feature editor for detail-rich stylogen inversion and high-quality image editing introduces the style feature editor, a novel approach for improving the quality and detail of images generated through stylogen inversion. Stylogen is a generative adversarial network that excels at creating high-quality images, but the inversion process converting a given image back into the latent space often loses fine details. The style feature editor addresses this issue by focusing on preserving and enhancing these details during inversion and editing. The key innovation of the style feature editor lies in its ability to manipulate features at different levels of the GAN's architecture. By selectively editing features at various layers, the method can fine-tune the appearance of the generated images without compromising their overall quality. This results in more realistic and detail-rich images, making the inversion process more robust and effective. The paper provides a comprehensive analysis of the style feature editor's performance, comparing it to existing methods in terms of image quality and detail preservation. The results demonstrate significant improvements, particularly in challenging scenarios where fine details are crucial. The authors also discuss potential applications of this technology, including photo editing, content creation, and virtual reality, where high-quality image generation is essential. Instruction pre-training language models are supervised multitask learners explores the concept of instruction pre-training, a technique that enhances the multitask learning capabilities of language models. Traditional language models are trained on large corpora of text, learning to predict the next word in a sentence. However, this approach does not explicitly teach the models to follow instructions or perform specific tasks. Instruction pre-training addresses this gap by training models on datasets that include explicit instructions, making them more adept at handling a variety of tasks. The process involves creating a diverse set of tasks, each accompanied by detailed instructions. These tasks cover a wide range of domains, including natural language understanding, text generation, and question answering. The model is then pre-trained on this dataset, learning to interpret and follow the instructions to complete the tasks. This pre-training phase equips the model with a broad understanding of how to handle different types of instructions, improving its performance on unseen tasks. The paper presents extensive experiments to validate the effectiveness of instruction pre-training. The results show that models trained with this approach outperform traditional models on a variety of benchmarks. The authors highlight the versatility of instruction pre-trained models, which can be fine-tuned for specific applications with minimal additional training. This makes them particularly valuable for practical applications where models need to handle a diverse set of tasks efficiently. Hare-human priors. A key to small language model efficiency introduces the Hare framework, which leverages human-like priors to enhance the efficiency of small language models. Human-like priors refer to the incorporation of knowledge and heuristics that humans use to understand and process language. By embedding these priors into language models, the Hare framework aims to improve their performance while keeping the model size manageable. The authors describe the process of integrating human-like priors into the model architecture. This involves encoding common-sense knowledge, linguistic rules, and contextual information that humans naturally use when interpreting language. The Hare framework also employs techniques such as transfer learning and multitask learning to further enhance the model's capabilities. These methods enable the model to learn from related tasks and generalize better to new ones. Extensive experiments are conducted to evaluate the performance of the Hare framework. The results indicate that models using human-like priors achieve comparable or superior performance to larger models, but with significantly reduced computational resources. This makes the Hare framework particularly suitable for applications where computational efficiency is critical, such as mobile devices and real-time processing. PRISM, a framework for decoupling and assessing the capabilities of VLMs, proposes the PRISM framework to evaluate visual language models VLMs more effectively. VLMs are designed to process and generate both visual and textual information, but their capabilities can be difficult to assess due to the complexity of the tasks they handle. The PRISM framework addresses this challenge by decoupling the various capabilities of VLMs and assessing them individually. The framework breaks down the evaluation process into several components, each targeting a specific capability of the VLMM. These components include visual understanding, language comprehension, and the ability to generate coherent and contextually appropriate responses. By isolating these capabilities, the PRISM framework provides a more granular and accurate assessment of the model's strengths and weaknesses. The paper details the implementation of the PRISM framework and presents a series of experiments to validate its effectiveness. The results demonstrate that the framework can identify specific areas where VLMs excel and where they need improvement. This information is valuable for researchers and developers looking to refine their models and enhance their performance. The PRISM framework sets a new standard for the evaluation of VLMs, providing a comprehensive and systematic approach to assessing their capabilities. MBench Video, a long-form multi-shot benchmark for holistic video understanding, introduces MBench Video, a new benchmark designed to evaluate the holistic understanding of long-form and multi-shot video content. Traditional video understanding benchmarks often focus on short clips or single-shot scenarios, which do not capture the complexity of real-world video content. MBench Video addresses this limitation by providing a more comprehensive and challenging benchmark. The benchmark consists of a diverse set of videos, each accompanied by detailed annotations and tasks that require holistic understanding. These tasks include activity recognition, temporal segmentation, and narrative comprehension, among others. The benchmark is designed to test the model's ability to integrate information across multiple shots and long time spans, reflecting the complexity of real-world video content. The authors describe the process of creating the MBench Video benchmark, highlighting the challenges involved in curating and annotating the videos. They also present baseline results using state-of-the-art video understanding models, demonstrating the difficulty of the tasks and the gaps in current model performance. The paper concludes with a discussion on the potential impact of MBench Video on advancing video understanding research and the development of more robust and comprehensive models. Whiteboard of Thought, Thinking Step by Step Across Modalities, explores the integration of multimodal data, enabling AI systems to reason and think in a step-by-step manner across different types of information such as text, images, and audio. The Whiteboard of Thought framework is designed to mimic the human cognitive process by sequentially processing and integrating data from various modalities. This approach enhances the model's ability to understand complex scenarios and generate more accurate and contextually relevant outputs. The core innovation of this framework lies in its ability to decompose tasks into smaller, manageable steps that can be independently processed and then integrated to form a comprehensive understanding. By doing so, the model can handle intricate tasks that require a combination of visual, auditory, and textual information. The authors provide detailed insights into the architecture of the whiteboard of thought framework, highlighting the mechanisms that enable it to process multimodal data effectively. Extensive experiments demonstrate the framework's superior performance in tasks requiring multimodal reasoning, such as visual question answering, audio-visual scene analysis, and context-aware text generation. The results indicate significant improvements over traditional models that handle modalities independently. The paper also discusses potential applications of this framework, including advanced AI assistants, enhanced content generation, and more sophisticated human-computer interaction systems. Invertible consistency distillation for text-guided image editing in around 7 steps presents a novel method for text-guided image editing that ensures consistent and high-quality results through a process called invertible consistency distillation. This approach focuses on maintaining the consistency of the edited images with the original text instructions, ensuring that the modifications accurately reflect the desired changes. The method involves a 7-step process that integrates text instructions into the image editing workflow. It starts with a pre-trained language model to interpret the text instructions and generate a latent representation. This representation is then used to guide the image editing process, ensuring that the changes align with the original instructions. The invertible consistency distillation mechanism ensures that the edits are reversible, allowing for fine-tuning and adjustments without compromising the overall quality. The authors provide detailed descriptions of each step in the process, highlighting the challenges and solutions involved in maintaining consistency between the text and the edited images. They present experimental results demonstrating the effectiveness of their approach, with significant improvements in both the accuracy and quality of the edited images compared to existing methods. This method has potential applications in creative content generation, interactive image editing, and AI-driven design tools. Model merging and safety alignment. One bad model spoils the bunch addresses the challenges of model merging and safety alignment in AI systems. Model merging involves combining multiple pre-trained models to enhance performance or incorporate new capabilities. However, this process can introduce safety risks if one of the models contains harmful or biased behaviors. The paper explores strategies to ensure that the merged model maintains safety and aligns with ethical guidelines. The authors propose a robust framework for model merging that includes thorough evaluation and alignment checks. This framework involves assessing each model's behavior individually and in combination with others to identify and mitigate potential risks. The process includes techniques such as adversarial testing, safety constraints, and alignment with predefined ethical standards. The paper presents case studies and experimental results, demonstrating the framework's effectiveness in maintaining safety and alignment during the model merging process. These results highlight the importance of rigorous evaluation and the potential risks of neglecting safety considerations. The authors conclude with recommendations for best practices in model merging, emphasizing the need for continuous monitoring and evaluation to ensure that merged models remain safe and aligned with ethical principles. PIN-R knowledge-intensive dataset for paired and interleaved multimodal documents introduces the PIN dataset, designed to enhance the capabilities of AI systems in processing and understanding complex, knowledge-intensive multimodal documents. These documents often contain interleaved text and visual elements that require sophisticated interpretation and reasoning to understand fully. The PIN dataset includes a diverse collection of documents from various domains, each paired with detailed annotations and knowledge-intensive tasks. These tasks require the model to integrate information from both text and visual elements, demonstrating a deep understanding of the content. The dataset is designed to challenge existing models and provide a robust benchmark for evaluating their performance. The authors describe the methodology for creating the PIN dataset, including the selection of documents, annotation process, and task design. They also present baseline results using state-of-the-art models, highlighting the challenges and opportunities for improvement. The paper concludes with a discussion on the potential impact of the PIN dataset on advancing research in multimodal understanding and the development of more capable AI systems. Gleiner Multitask Generalist Lightweight Model for various information extraction tasks proposes the Gleiner Multitask Model, designed to handle a wide range of information extraction tasks with high efficiency and accuracy. And traditional models often require separate training for each specific task, leading to inefficiencies and increased computational costs. The Gleiner Multitask Model addresses this by using a single, lightweight architecture capable of performing multiple tasks simultaneously. The model leverages transfer learning and multitask learning techniques to achieve this versatility. It is pre-trained on a diverse set of information extraction tasks, allowing it to generalize well to new tasks with minimal additional training. The authors provide a detailed description of the model architecture, including the mechanisms that enable it to handle different tasks effectively. Extensive experiments demonstrate the Gleiner multitask model's superior performance across various benchmarks, with significant improvements in both accuracy and efficiency compared to traditional models. The results highlight the model's potential for practical applications in fields such as natural language processing, data mining, and information retrieval. The paper concludes with a discussion on the broader implications of this approach for developing more versatile and efficient AI systems. DigGirl training in the wild device control agents with autonomous reinforcement learning introduces DigGirl, a framework designed to train device control agents in real-world environments using autonomous reinforcement learning. Traditional reinforcement learning methods often require controlled environments and extensive human supervision, limiting their applicability in dynamic, real-world scenarios. DigGirl addresses this by enabling agents to learn and adapt autonomously in diverse and unpredictable settings. The framework leverages a combination of simulation and real-world data to train the agents. Initially, the agents are trained in a simulated environment that mimics real-world conditions. This allows them to develop a basic understanding of the tasks and acquire essential skills. Once the agents achieve satisfactory performance in the simulation, they are deployed in the real world, where they continue to learn and adapt through autonomous reinforcement learning. The authors present a detailed description of the DigGirl architecture, including the algorithms and techniques used to ensure effective learning and adaptation. They also discuss the challenges of transferring knowledge from simulation to real-world environments and the strategies employed to overcome these challenges. Experimental results demonstrate the effectiveness of DigGirl in training device control agents for a variety of tasks, highlighting its potential for practical applications in robotics, automation, and smart devices. Iterative Length Regularized Direct Preference Optimization, a case study on improving 7 billion language models to GPT-4 level, introduces a novel optimization technique aimed at enhancing the performance of large language models, specifically targeting the improvement of 7 billion parameter models to reach GPT-4 level capabilities. The technique, known as Iterative Length Regularized Direct Preference Optimization (LDPO), focuses on refining the model's preferences through a series of iterative adjustments, guided by length regularization. The Illinois DPO technique involves fine-tuning the model by optimizing its response length preferences. By incorporating length regularization into the optimization process, the model learns to generate responses that are not only accurate but also appropriately concise or detailed, depending on the context. This iterative approach allows the model to gradually refine its preferences and improve its overall performance. The paper provides a comprehensive analysis of the LDPO technique, detailing the algorithms and methods used to implement it. The authors present extensive experimental results, demonstrating significant improvements in the performance of 7 billion parameter models across various benchmarks. The findings indicate that LDPO can effectively bridge the gap between smaller models and their larger counterparts, offering a promising avenue for enhancing the capabilities of large language models without the need for prohibitively large architectures. Improving visual common sense in language models via multiple image generation explores the enhancement of visual common sense reasoning in language modeled through the use of multiple image generation. Visual common sense refers to the ability of a model to understand and reason about everyday visual scenes in a manner similar to human cognition. Traditional language models often struggle with this aspect due to the lack of visual context in their training data. The proposed approach involves generating multiple images that correspond to different aspects of a given text description. These images provide the model with a richer visual context, enabling it to develop a deeper understanding of the described scene. The generated images are used to augment the training data, allowing the model to learn visual common sense reasoning more effectively. The authors describe the methodology for generating the images and integrating them into the training process. They present experimental results demonstrating significant improvements in the model's ability to perform visual common sense reasoning tasks. The findings suggest that this approach can enhance the model's overall understanding and generation of contextually appropriate responses, with potential applications in areas such as image captioning, visual question answering, and multimodal content generation. Xvideo extending video diffusion models via parameter-efficient post-tuning introduces Xvideo, a novel approach to extending the capabilities of video diffusion models through parameter-efficient post-tuning. Video diffusion models are used to generate high-quality video content by diffusing patterns and textures over time. However, these models often require extensive computational resources and large datasets for effective training. The Xvideo approach addresses these challenges by focusing on parameter-efficient post-tuning, which allows for the fine-tuning of pre-trained video diffusion models with minimal additional computational overhead. This technique involves adjusting a small subset of the model's parameters based on new data, enabling the model to adapt to new video content and generate high-quality results with reduced resource requirements. The paper provides a detailed description of the Xvideo methodology, including the algorithms and techniques used for parameter-efficient post-tuning. The authors present experimental results demonstrating the effectiveness of Xvideo in extending the capabilities of video diffusion models, highlighting improvements in video quality and generation efficiency. The findings suggest that Xvideo offers a promising solution for enhancing video generation models in a resource-efficient manner, with potential applications in content creation, film production, and virtual reality. Self-play with execution feedback improving instruction following capabilities of large language models introduces a novel training technique designed to enhance the instruction following capabilities of large language models. The technique, known as self-play with execution feedback, involves training the model to follow instructions by simulating interactions and providing feedback on the execution of the instructions. The self-play mechanism allows the model to generate instructions and execute them in a simulated environment, receiving feedback on its performance. This feedback loop helps the model learn from its mistakes and refine its ability to follow instructions accurately. By iteratively improving its instruction following capabilities through self-play and feedback, the model becomes more adept at handling a wide range of tasks. The paper details the implementation of the self-play with execution feedback technique, including the algorithms and methods used to simulate interactions and provide feedback. The authors present experimental results demonstrating significant improvements in the model's instruction following performance across various benchmarks. The findings indicate that this approach can effectively enhance the capabilities of large language models, making them more reliable and versatile for practical applications. LiveMind low-latency large language models with simultaneous inference introduces LiveMind, a system designed to achieve low-latency inference for large language models by enabling simultaneous processing. Traditional inference methods often suffer from delays due to the sequential nature of processing, which limits the model's ability to respond in real-time applications. LiveMind addresses this by leveraging parallelism and efficient resource management to minimize latency. The core of LiveMind's approach involves dividing the inference task into smaller, manageable chunks that can be processed concurrently. This is achieved through advanced scheduling algorithms and optimized hardware utilization, allowing the model to generate responses more quickly without sacrificing accuracy. The system is designed to handle high throughput, making it suitable for applications that require real-time interaction, such as chatbots, virtual assistants, and interactive content generation. Experimental results presented in the paper demonstrate significant reductions in latency, with LiveMind achieving real-time performance even for large and complex models. The authors highlight the scalability of their approach, showing that it can be adapted to different model sizes and hardware configurations. This makes LiveMind a versatile solution for deploying low-latency language models in various real-world scenarios. RepoExec Evaluate Code Generation with a repository-level executable benchmark introduces RepoExec, a comprehensive benchmark designed to evaluate the performance of code generation models at the repository level. Traditional benchmarks for code generation often focus on isolated functions or snippets, which do not capture the complexity of real-world software projects. RepoExec addresses this by evaluating models based on their ability to generate and execute code within the context of entire repositories. The benchmark includes a diverse set of repositories from various domains, each with detailed annotations and evaluation criteria. These criteria assess the model's ability to generate syntactically correct, functional, and efficient code that integrates seamlessly with existing project structures. By focusing on repository-level evaluation, RepoExec provides a more realistic assessment of code generation capabilities. The authors describe the methodology for creating the benchmark, including the selection of repositories and the development of evaluation metrics. They present baseline results using state-of-the-art code generation models, highlighting the challenges and opportunities for improvement. The paper concludes with a discussion on the potential impact of RepoExec on advancing research in code generation and the development of more robust and capable models. Model internals-based answer attribution for trustworthy retrieval augmented generation proposes a novel method for enhancing the trustworthiness of retrieval augmented generation RAG systems by leveraging model internals for answer attribution. RAG systems combine the strengths of retrieval-based and generative models to produce accurate and contextually relevant responses. However, these systems often struggle with providing transparent and trustworthy answers, as the sources and reasoning behind the generated content are not always clear. The proposed method involves analyzing the internal representations of the model to trace the sources and reasoning steps that contribute to the final answer. This allows for a more transparent and interpretable generation process, where users can understand how and why certain information was retrieved and used in the response. The authors present detailed insights into the implementation of this method, highlighting the techniques used to extract and interpret model internals. Experimental results demonstrate significant improvements in the trustworthiness and interpretability of RAG systems using the proposed method. The findings suggest that this approach can enhance the user experience by providing more transparent and reliable answers, with potential applications in areas such as customer support, education, and content generation. A systematic survey of text summarization from statistical methods to large language models provides a comprehensive overview of the evolution of text summarization techniques, from early statistical methods to modern large language models. Text summarization aims to condense long documents into concise and informative summaries, making it easier for users to quickly grasp the key points. The survey covers a wide range of techniques, highlighting their strengths and limitations. The authors begin by discussing the early statistical methods, such as frequency-based and graph-based approaches, which rely on simple heuristics to identify important sentences and phrases. These methods are computationally efficient but often produce summaries that lack coherence and depth. The survey then moves on to more advanced techniques, including neural network-based models and attention mechanisms, which have significantly improved the quality of summaries. The paper provides an in-depth analysis of the latest advancements in text summarization, focusing on the capabilities and challenges of large language models. These models leverage vast amounts of data and sophisticated architectures to generate high-quality summaries that are both informative and coherent. The authors discuss the current state-of-the-art models, such as BERT, GPT, and their variants, highlighting their performance on various benchmarks and real-world applications. Stable semantics, a synthetic language vision dataset of semantic representations in naturalistic images, introduces stable semantics, a synthetic dataset designed to facilitate the study of semantic representations in naturalistic images. The dataset includes a diverse collection of images, each paired with detailed semantic annotations that describe the objects, actions, and relationships present in the scene. This allows researchers to explore how AI models understand and represent visual information in a structured and meaningful way. The authors describe the methodology for creating the stable semantics dataset, including the generation of synthetic images and the annotation process. They emphasize the importance of diversity and realism in the dataset, ensuring that it captures a wide range of scenarios and visual elements. The dataset is designed to be used in conjunction with various language vision tasks, such as image captioning, visual question answering, and scene understanding. Experimental results demonstrate the utility of the stable semantics dataset in training and evaluating language and language vision models. The findings suggest that the dataset can help improve the performance of models on tasks that require a deep understanding of visual semantics. The paper concludes with a discussion on the potential impact of stable semantics on advancing research in language vision integration and the development of more capable AI systems. $T$Bench, a benchmark for tool-agent user interaction in real-world domains, introduces $T$Bench, a comprehensive benchmark designed to evaluate AI tool agents' performance in real-world domains. These tool agents are intended to assist users by executing various tasks and interacting with different tools and environments. The benchmark aims to assess the agent's ability to understand and execute complex instructions, adapt to dynamic environments, and interact effectively with human users and other tools. The benchmark includes a wide range of tasks that reflect real-world scenarios, such as document editing, data analysis, and software development. Each task is designed to test specific aspects of the tool agent's capabilities, including natural language understanding, contextual reasoning, and multi-step execution. The benchmark also includes detailed evaluation metrics to measure the agent's performance, accuracy, and efficiency. The authors describe the methodology for creating the $T$Bench benchmark, including the selection of tasks and the design of evaluation criteria. They present baseline results using state-of-the-art tool agents, highlighting the challenges and opportunities for improvement. The paper concludes with a discussion on the potential impact of $T$Bench on advancing research in AI tool agents and the development of more capable and reliable systems. Sampling 3D Gaussian scenes in seconds with latent diffusion models presents a novel approach for generating 3D scenes quickly and efficiently using latent diffusion models. Traditional methods for 3D scene generation often require extensive computational resources and long processing times, making them impractical for real-time applications. The proposed approach leverages latent diffusion models to generate high-quality 3D scenes in a fraction of the time. The method involves training a latent diffusion model on a dataset of 3D scenes, allowing it to learn the underlying patterns and structures. Once trained, the model can generate new 3D scenes by sampling from the latent space and applying diffusion processes to refine the output. This results in realistic and detailed 3D scenes that can be produced in seconds, making the approach suitable for applications such as virtual reality, gaming, and architectural visualization. The authors provide a detailed description of the model architecture and the training process, highlighting the techniques used to achieve high-quality results with low latency. They present experimental results demonstrating the effectiveness of their approach, with significant improvements in both speed and quality compared to traditional methods. The paper concludes with a discussion on the potential applications and future directions for research in 3D scene generation using latent diffusion models. From insights to actions, the impact of interpretability and analysis research on NLP explores the role of interpretability and analysis research in advancing natural language processing (NLP) technologies. As NLP models become increasingly complex and capable, understanding how they work and ensuring their reliability and fairness becomes crucial. This paper reviews the current state of interpretability and analysis research in NLP, highlighting key advancements and their impact on the development and deployment of NLP systems. The authors discuss various techniques for interpreting and analyzing NLP models, including attention mechanisms, saliency maps, and counterfactual analysis. These techniques provide insights into the inner workings of the models, helping researchers and practitioners identify biases, improve performance, and ensure ethical use. The paper also explores the practical implications of interpretability research, such as enhancing model transparency, building user trust, and facilitating regulatory compliance. Experimental results and case studies presented in the paper demonstrate the benefits of incorporating interpretability and analysis techniques into NLP workflows. The authors conclude with a discussion on the future directions for research in this area, emphasizing the importance of ongoing efforts to make NLP models more transparent, reliable, and aligned with human values.